Here we go with another interesting question. Let us go through the exercise together. It says, assuming the pendulum bulb is in the figure below is oscillating in a vacuum, determine its maximum speed. We are to take g, the acceleration due to gravity, to be 10 meters per second squared. We are given this setup. It is a simple pendulum that swings to and fro. At this point, it has a maximum height of 1.3 meters from the ground level. And at this point, it has a minimum height of 1.1 meter from the ground level. So it swings this way, and then this way, and to and fro. This is the point where the height is maximum height from where the height from the ground is minimum, and this is the maximum height. You will agree with me that at this point it will stop and start to come down. It gets to somewhere here, it stops and goes back again and continues that oscillatory motion. The question is asking us to determine the maximum speed. Like we said, it will stop here, which means the speed at this point is 0. The height here is the maximum height. Let's call it uppercase letter h. The height here is the minimum height. Let's call it lowercase letter h. At the maximum height, the speed is 0 because it's going to stop momentarily. So let's call the velocity there 0. Uppercase letter v to correspond with the maximum height, uppercase letter h. This is the point where it's going to have the maximum speed, because as it's swinging down, it's going to have this highest speed at this point. That is the speed we are looking for. Let's call it v, lowercase letter v, question mark, to correspond with lowercase letter h, the minimum height. So this is the setup, and we are just going to be looking for v. You will agree with me that because it is oscillating in a vacuum, it means we are going to neglect, it means there is no air resistance, so we are not even neglecting it. There is no air resistance. So we are just going to solve this problem using the principle of the conservation of mechanical energy. According to the conservation of mechanical energy, the sum of the energy here must be equal to the sum of the energy here. You agree with me that at this point, the body possesses both kinetic and gravitational potential energy. Similarly, here, the body possesses both kinetic and gravitational potential energy. So the sum of the kinetic energy and potential energy here must be equal to the kinetic energy and potential energy here. So we can say kinetic energy Ke plus potential energy Pe equals Ke plus Pe. The uppercase represents the energy here, while the lowercase represents the sum of the energy here. Let's recall the equations. Kinetic energy is given as half mv squared, while potential energy, gravitational potential energy, is given as mgh. The uppercases are here to tell you we are talking about this parameter here, while the lowercase tells us we are talking about the parameter here. And our target is to find the value of this v. So let's solve the problem. You would have noticed that we have mass and mass, so we can factorize it out. Similarly, we have mass, we can equally factorize it out. If we have mass on the right hand side and we have mass on the left hand side and they are equal, then they can cancel out, which means we can ignore the masses and we'll be left with half v squared plus gh equals half v squared plus gh. Let's solve for v by substituting in the values. So we have half times 0 because the velocity at this maximum height is 0, plus 10, g is 10, times 1.3, the maximum height h, equals half v squared, we're looking for v, plus 10 to represent g, times 1.1, the height, minimum height. Let's move to the next page. So this is what we've got. So we're going to solve from here. Half times 0 is 0. 10 times 1.3 gives us 13. So on the left hand side we have 13. Half v squared plus 10 times 1.1 is 11. We want to get v squared. To take away this denominator of 2, let's multiply the equation by 2. So that 2 multiplies 13 to give us 26. 2 multiplies half to give us 1. So we have v squared plus 2 multiplies 11 to give us 22. Of course, v squared will be the difference, 26 minus 22. And 26 minus 22 is 4. So v squared is equal to 4. To obtain v is simple. We take the square root of both sides, which means v will be the square root of 4, and that is 2. So the velocity, the maximum speed at this point is 2 meters per second squared. Don't worry about the negative that is supposed to be here, because you would say v will be plus or minus square root of 4. Velocity is not negative. We are not going to be ignoring that. We are just looking for the maximum velocity or the maximum speed at this point without the direction. So we have it as 2 meters per second. Very simple, very straightforward. I am very sure you enjoyed this video and you understood it as well. If you did, like it, share it to your learning colleagues and friends, and drop your comments in the comment section. Follow our page if you have not done so, and if you are watching this video on YouTube, consider subscribing so that you will keep getting educational content from us. Thank you again for watching this video, and I hope to see you in our next video.